All right, so here's our first example of a single case design. And this is, in a lot of ways, just going to resemble a repeated measures or within subjects experimental design, but it is something you would carry out with just one participant. So this first type we would generally call an A-B design. You might colloquially call it something like a pre-test, post-test design, or a control treatment design as well. The kind of basics of this, the A-B part comes from the A represents the baseline measurement, which is a lot like a control condition in an experiment. And the B represents the outcome measurement that comes after a treatment. So the A, control or baseline, the B, outcome or post-test in a lot of ways. So if you were doing a single case design that was just A, B in nature, your data might end up looking something like this. The y-axis here, the frequency of responses, and the x-axis, just the observation periods in days. So the treatment happens in the middle. You get a baseline. Generally, when you're only doing a single case design, you're not just going to do one measurement before and one measurement after because you want to get a better estimate of what that baseline is for that person. So you would have usually several measurements before the treatment. The treatment happens, and then you see whether that treatment affects the frequency of responses or the types of answers people give or whatever your DV happens to be. So in this case, this is evidence suggesting that the treatment reduced the frequency of responses in this hypothetical example. So you are doing this presumably to show that your independent variable, your treatment, is causing a change in your dependent variable, right? But because this is only one person, it is difficult to say that this is representative at all, right? That this would generalize to other people. It's maybe showing that this is a possible effect, but not that it is, has a lot of external validity. Furthermore, this resembles something that we've already talked about, right? These types of designs, in a lot of ways, resemble some of the quasi-experimental designs we talked about. The quasi-experimental ones would have more participants, right? They would have pre-existing groups sometimes, or just one, convenient sample of people. But this is akin to some of those things that we talked about there. The big problem is or there's a number of big problems, but this is subject to a lot of the same limitations as those quasi experiments. The treatment maybe just happened to coincide with some sort of event in the world, or maybe there was something co-occurring with the treatment, or maybe there was something else going on in that person's life, right? There could be any number of things that are leading to this change without it necessarily being the treatment. So to improve on this type of design, you might do what's called a reversal design or an ABA design. ABA because you're going from baseline to post-treatment back to baseline, and that's the reversal part of it. You're reversing the treatment. So this is a type of design that might not always be totally possible, right? If you have some sort of treatment that should be a permanent change in someone, this would not be an appropriate design, right? So, for example, if you're trying to test the effectiveness of some sort of instruction method or teaching intervention, this would not really be an appropriate design because you're assuming that once you've taught something, people are going to know it, right? So you wouldn't expect anyone to go back to baseline. But if it's something, like trying to reduce anxiety and that treatment should just be kind of temporary, then this would be an appropriate way to do it and also show that the treatment really is what is leading to the change that you observe. So in these ABA or reversal designs, it's basically the same as an AB design, but just then removing the treatment and continuing to measure. So it might look something like this, where you have your baseline, you're measuring, your treatment is introduced, your dependent variable has hopefully the change that you're looking for, but then you remove the treatment, so you're able to see that your dependent variable goes back to baseline. So this is somewhat stronger evidence that the treatment really is doing something, because you introduced the treatment, a change was observed, you removed the treatment, and the variable that you're measuring went back to normal, or your baseline. So again, this doesn't completely eliminate the possibility that there are just, historical things happening, or, unrelated things going on. So there's yet another type of these designs that just adds another condition, basically. This is still a type of reversal design, but an ABAB design is, as you're probably guessing, because it's relatively obvious as we keep adding these letters, you're just basically doing two AB designs in a row. Baseline treatment, baseline treatment. So you have two sets of post-tests here. So an ABAB design would look something like this. You measure a baseline, you introduce a treatment, continue to measure, remove the treatment, measure back at baseline, introduce the treatment again, and you can, observe that change if it exists. So again, this does help make a slightly more convincing argument for causality, but this is never going to be as convincing a bit of evidence as a true experiment where you are randomly assigning people to your different conditions and you're eliminating a lot of those alternative explanations. The internal validity here is never going to be as good or as high as a true experiment, but it's still can be useful evidence if you have limitations of time, money, safety, ethics, whatever it happens to be. This might be your only option for some sorts of phenomena that you're trying to observe, even though it's not as good of evidence as a real experimental design. The last type of design I want to talk about before I move to talking about longitudinal or developmental studies are some different types of multiple baseline designs. So these are types of studies where you might be trying to increase the external validity that you have in these types of studies by basically doing different single case studies at the same time. In different contexts or in different situations. But you are going to hopefully be able to introduce the treatment at different times so you can see if the treatment works across all those different situations. So if you are able to do this, then you're going to be able to show people, look, I basically replicated my findings, conceptual replications of my findings with this participant across these different situations. So let me show you what I mean. If you were doing a multiple baseline with different subjects, it would just be basically that you are doing the same type of A/B design with different people at the same time. So let's think about this example is people on a basketball team, and you're giving them some kind of intervention to help them, shoot shots that they're more likely to make, basically shooting layups instead of long three-pointers, basically. So maybe you have a team where it's all ball hogs that just want to shoot three-pointers, and you need to change that up so they're making shots that they're more manageable and more likely to make. So if you introduce a treatment at different times for different players, like a strategy to get them to reconceptualize how they're thinking about shooting and accumulating points, you might be able to see if your intervention is actually working. So you see here we have Beth, Carol, and Ariane, and the treatment is being introduced at different times for each of them. This evidence would suggest that this treatment is probably not the cause of the change that we're observing in them. Because you see, for Beth, it does kind of seem like the treatment works. We introduce the treatment, suddenly she's shooting 80% of her shots as easy or high percentage shots compared to about 20% before. But if you look at the other participants, you'll notice that the change for them started at about the same time. So the treatment here probably isn't actually the cause of what's going on. Maybe there happened to be a very like popular basketball player at the time who made a big deal that they stuck to high percentage shots, and that was like fundamentals are great. This is how you get good at basketball. And maybe that mattered. And it just happened to coincide with your treatment. And that might explain why you're seeing these changes ahead of the treatment for the other two players. So multiple baseline designs where you're using more than one subject or participant can help you reveal alternative explanations for what you're observing as changes in your design. A different way we might do it is to look across different behaviors. So let's imagine that you are trying to help somebody be more assertive or outgoing in therapy. You might want to look at their assertiveness or their extroversion and outgoing behaviors across different situations to make sure that the treatment that you're using actually was helping this person. So sorry, this is so small, even I have to kind of look up here a little bit awkwardly. But we're looking at ratio of eye contact to speech duration, so how much they're making eye contact, basically. Loudness of speech, number of requests they're making to people, and their overall assertiveness in some way. So if you had some sort of therapeutic treatment that you were introducing to this person by this dotted line here, showing when it was introduced, basically, you could look at this across different behaviors. And if you notice a change across all these different outcomes, then that might be good evidence that your treatment is working. If you only did one of these studies, like if you only did the first one with your patient, and you notice this big jump in assertiveness, then you might falsely assume that because they're making more eye contact, that they are just more assertive in general. But if you looked at these other ones, then you might have a little bit of skepticism then that the intervention worked quite as well as you thought, because the number of requests they're making, it went up a little bit, but it went from 0 to 1. That's not the biggest change in the world, perhaps. So maybe this would give you an idea that there's more work to be done with this patient, even though the treatments do seem to be working. They weren't changing on their own. It didn't seem to be some other sort of outside event, but you'd get very different pictures if you were looking at only one of these outcomes instead of all three. Okay, the last one is when you might be looking across different situations. So this particular example, it's about reducing negative behavior at school. Maybe there is a lot of bullying or other problems or something going on at school. So we're looking at different problem behaviors in a particular school, and we want to look at how those problem behaviors are when the students are entering school, when they're entering the cafeteria, and when they're exiting school. And we have some kind of treatment, maybe some sort of lesson that people are getting in homeroom, whatever it happens to be. But if you introduce this treatment at different times for these different situations, then you might be better able to conclude that your treatment really is working. And this one, like the last one, does seem to be working. You have kind of converging evidence that the behaviors are reducing in frequency after the treatment is introduced. But you also have these kind of complementary pieces of evidence showing that it really worked in one domain and it maybe didn't work quite as well, or the trend was already starting in another domain. Okay, so these obviously are not perfect types of designs, right? I hope that obviously I've kind of harped on that from the beginning, that these have limits of their external validity because they're usually just one person or one situation, and they have limits on their internal validity because you are not randomly assigning people to these groups. So these multiple baseline designs tend to help because you're kind of replicating your own single case designs, basically. But they might not rule out things like participants telling each other about treatments in those multiple subject designs. They definitely don't reduce things like expectancy effects. That experimenters might observe what they want to observe, basically. They don't rule out things on the participant end, like how you might just behave differently because you know you're being observed. We call that a number of things: novelty effects, Hawthorne effects, reactivity. People don't act exactly as they naturally would if they know that they're being evaluated or observed. So, I mean, that's a problem in any type of research, but particularly these single case studies. There's a lot of focus on a single person in these. And as I've already mentioned more than once, like case studies, these do really lack external validity. They are not representative, and they, by virtue of just having one or a few participants in the multiple baseline case, they don't allow for that type of random assignment. But I don't say all this stuff to just say that experiments are perfect and the only type of research anyone should do. That's not the point of going over these other types of designs. But experiments do have some very unique qualities that are important for figuring out causality. But that's just one of the things that you need to think about in terms of trade-offs when you're trying to determine what design you should be using.